Okay, today we're going to be graphing tan. Here's the parent graph of tan. It's important to know the parent graph because you can identify the asymptotes and the roots. And roots, if you remember, are where the graph crosses or touches the x-axis. So that on the function we're graphing, we can get the roots and we can get the asymptotes so we can accurately graph it. So looking here, you notice that on the parent graph, we have the roots. Zero. Now on the parent graph, we know that the root is 0. On this new graph, where we're tan of 4x, we have to find out where the new root is. So in this case, if we divide both sides by 4, our first root is 0. Now we're going to go to our second root, which is pi. Dividing both sides by 4, our next root is pi over 4. Going to the 2 pi, next root, dividing both sides by 4. Our last root on the right side is pi over 2. Now if we went through and we did this exact same process for the left side of the graph, you would see it is a mere reflection because these are periodic functions and they're predictable. So if this is positive pi over 4, this is going to be negative pi over 4. If that's positive over 2 is a root, positive pi over 2 is a root, then negative pi over 2 is also a root. And now we're going to go through and identify asymptotes. We're going to use the identical process. So we are going to, actually I'll put it where you can see it. We are going to take the first asymptote, which is pi over 2, divide by 4. Dividing by 4 is the same as multiplying by the reciprocal, 1/4, and that gives us pi over 8. So right here is our first asymptote at pi over 8. For the next asymptote, we take what's called the argument, and that's what you're tanning. And we're going to do 4x equals, we're going to go to our second asymptote, 3 pi over 2. Divide both sides by 4, we're just saying multiplying by 1/4, and we get 3 pi over 8. We now have our second asymptote, 3 pi over 8. Again, it's a periodic function, so if there's an asymptote at positive pi over 8, there is an asymptote at negative pi over 8. If there's an asymptote at 3 pi over 8 in this case, negative 3 pi over 8. And now we, using the roots and the asymptotes as our guide, remember a graph asymptote is an imaginary line that the graph never crosses, and that would be our function.